Hi everybody. Once again, welcome back. We're here to talk about the Leslie matrix. Leslie matrix is good for birth rates and survival rates of different species, both real and fictitious. Unless you are someone very special or really addicted to Harry Potter and have some sort of convoluted idea, then you will understand that the Pegasus is actually a fictitious animal. A winged horse, a white winged horse, especially one that helps out Perseus in the Wrath of the Titans, or the Clash of the Titans, I apologize, actually I think it's both, is actually not a real animal. You don't have winged horses. But for the sake of the Leslie matrix, we can talk about that. Now, what we have here is we have a birth rate and we have a survival rate. Birth rate, very simple. These are your transition periods. So from 0 to 5 years, Pegasus is not breeding, and half of Pegasuses are dying. So they only have a 50% chance of living after their first 5 years. Now once they get to 5 to 10, their survival rate goes up to 70%, and half of them start breeding. 10 to 15, we have that 1.1 is our birth rate, and 0.9% are surviving, so 0.9 is a much better topic. 8.8 is still okay. Then we go to 7, and then when we get to 25 to 30, it's 0. Why? Because they all die. From 25 to 30 years old, that's their life expectancy. Their maximum age of the Pegasus is 25 to 30 years. Okay, that's as far as it goes. That's their last ditch effort to survive. Okay. Now, it says determine the population after 15 years. If every single one of these is 5 years, then that means that 15 years would be 3 transitions, because a transition is 5 years. So how would I figure that out? First thing I need to do is construct my matrix. Birth rates go down the top, go down the first column. 0, 0.5, 1.1, 0.9, 0.3, and 0. And then we have the survival rates that go diagonal. So we have 0.5, 0.7, 0.9, 0.8, and 0.7, because obviously, once again, we have all zeros all across the board. So 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 4, 5, and 6. No, that's 6. Never mind. That's 6. And then, okay? So there's our matrix. That's what your matrix should look like. Okay? Now, this is the Leslie matrix. For this particular problem, that is the Leslie matrix. This is your population matrix. This is how many of each transition there are existing today. So if I need to find out what the population is after 15 years, I take my original population matrix, which is 18, 16, 14, 10, 7, and 2, and I multiply it by this, but since there's 3 of them, then you can either run it through 3 times, or you can simply raise it to the 3rd power, raising the Leslie matrix to the 3rd power. Not the answer to the 3rd power, not this to the 3rd power. Raise the matrix to the 3rd power, and that will give you your answer here. Okay? 40 years is going to be 8 transitions, so you simply do the original population, Leslie matrix, but this time you'll raise it to the 8th power. Okay? Explain what is happening. You should see some things. Why? Because apparently your birth rate is 110%. That seems to be a bit of an issue. How can you have 110% of them breeding if there's only 100% of them alive? So you should come up with some skewed answers with things. And that's part of what you're going to be looking to find when you explain things. But that's pretty much all you're going to do as far as the Leslie matrix goes. This is your Leslie matrix for this particular problem. This is your population matrix. You multiply your population times your Leslie to whatever power you need to find the number of transitions for that population at that time. Thank you guys so much. I hope that was helpful. Have a wonderful day.